Let's try out some list processing procedures that are built in. Append lists the elements of two different lists all in one list. Or, if you pass in multiple lists, more than two, you get one list with all the elements of each of the list arguments to append. Map calls some procedure f on each element of S, collects the results in a list. Filter calls some procedure f on each element of list S, and collects in a list all of the elements of S for which f returns a true value. Apply is a little bit different than map. It applies the procedure f to S as if that S were the list of arguments to f. So f only gets called once on all the elements of S together. Okay, let's quickly try each of these out, and then we'll work on an example. If I have a list S, cons 1, cons 2, nil, then appending S to itself just gives me the elements 1, 2, 1, 2. And I can append S a bunch of times in order to get all of the values in S, 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 and S, which is quite different than what you get if you list S 4 times, then you get a nested structure. If I call map with the even predicate on all the elements of S, then I find out that 1 is not even, but 2 is. And of course, I could map some procedure that I create on the fly. 2 times x has to be written like somebody's programming in Scheme. Go over all the elements of S, and you get 1 times 2 is 2, and 2 times 2 is 4. Filtering for only the even values in S gives you just the results in S that are even. So if I said 5, 6, 7, 8, 9, I would get just the 6 and the 8. If I ask which of these elements are lists, the number 5, the list 6, 7, the number 8, and the list containing only 9, then I'll find that the list elements are the list 6, 7, and the list 9. If I wanted to put 5 on the front of each such list, I could map the following procedure. For each list, I want a cons of 5 onto S, and then I'd get 5, 6, 7, and 5, 9. And then the last list processing procedure I mentioned is apply. When you apply some procedure like quotient to arguments 10 and 5, then it divides 10 by 5. Or if you apply plus to 1, 2, 3, 4, then it's as if I had applied plus to 1, 2, 3, and 4. Notice this is quite different than mapping plus over 1, 2, 3, 4, which is the same as making a list of plus 1, plus 2, plus 3, and plus 4, but that doesn't sum them up, whereas applying plus to a list does sum up the elements, and so you don't need a separate sum procedure in Scheme because you already have plus.